Ranak everybody. This video will be about courses and list of videos that will be created on the channel of FEArytales, and all this video will be about computational mechanics and Ansys Workbench. So we will take a look into the list of courses and courses structure. The list of courses contain two big parts. First of all, it's introduction to courses, Ansys Workbench introduction, review of CAD capabilities of Ansys Workbench product, introduction to Ansys Mechanical, Ansys Machine introduction, and some theoretical questions of computational mechanics. Every point in this list, it's several video, and the structure we will take a look later. And some of this video will be created in parallel because, for example, when we will talk about introduction to Ansys Mechanical and basic features and principles of working of Ansys Mechanical, we already need to talk about some theoretical question about finite elements, or about how to compute behavior of machine built instructions, and how these machine building structures works, why it works, why is it breaks, and so on. That's very big number of videos, so during today we will take a closer look and more detailed description about all these courses, and also I will talk very shortly about second part, because this part will be started only when I will end the first part of list of video. But it's very important to understand what type of materials I will create in the future. So second part contain some advanced question about information that we already talked. We will talk about nonlinear calculation in Ansys Workbench. We will talk about transient and dynamics behavior, about thermal and computational fluid dynamics tasks, some examples of industrial problem, real industrial problem from the field, and real practice, and some additional marketing materials like best practice, tips, tricks, and reviews of different software, not only Ansys Workbench. Some marketing materials also will be created in parallel for the first course, for reason of creating bigger audience. But in most cases, we will go from the beginning to the end, from the introduction of all courses to marketing materials, from video to video. So, short course, which I called Introduction to Courses, will have several videos, and it will start from the two short video. First of all, it's a quick start of Ansys Workbench. It's short tutorial, and second, it's a video which explain what's wrong with short tutorial and short introduction. First video will be only about practice, and second video will take more detailed view on some questions that we don't look on first video. So it's have such structure because you can find lot of short tutorial for any type of task on the YouTube from different authors, but in most cases, if you don't understand what did you do in this tutorial, why did you do that, what did you don't do during this tutorial, and a lot of additional questions, you will not be able to solve a real problem from the real life. And it will be a lot of problem if you will try to implement those tutorials to solving real problems. So we will talk about short tutorial and problem of this short tutorial. Additionally, we will talk about Ansys company and all software that Ansys have. We will talk about what type of task we can solve with this software, in which fields and in which direction we can solve our problems, where Ansys software can be helpful during solving design process and design problems. So something like that. Additionally, will be one video about course structure. It's this video currently, because couple video about quick start of Ansys Workbench we already have on this channel. Review will be later, and much later will be Ansys history, in reason that for my thoughts and things, I think that first of all user must receive and get a tool to solve their problem, and only after that they have something like a tool, it will be very interesting to watch and hear about history of this tool. So two video we already have. This video is the fourth on the list. Additionally, will be later video about Ansys company and software, and Ansys history will be much later. Before this video about history, we will talk about Ansys Workbench. We will create an introduction course to Ansys Workbench. It will be about 10 video. First of all, we will do a quick review of Ansys Workbench Project Manager, how does it work, why do we need a project manager, in reason that other CAE software doesn't have project manager, but Ansys have, and what benefits we will get from this project manager. Also, we will talk about some tools from Toolbox. We will talk about analysis systems. Analysis systems contain tools for creating task and problem from such direction as mechanics, as fluid dynamics, electromagnetics, acoustics, and a couple other direction. Also, we will talk about custom systems. It's additional tool from general purpose, with which you can create a finite element model, with which you can create a computational mesh for CFD. You can add different tool to work with geometry, with mesh, with optimization, with some specific tools like composites and so on. After that, it's a model which adds possibility of different Ansys product to your project, to your workflow. Design exploration, it's number of tools which help you to do researches of your designs to obtain optimal solution to understand how your construction work and which way is better for improving your construction and so on. Also, we will talk about top menu of Ansys Workbench, and we'll talk about some additional information, some tips and tricks of working with Project Manager. We will talk about them on the end because it's some repeat of first video, but more deep, with more information, with more tips, and all these tips can be reviewed if you don't have understanding about all possibilities of Ansys Workbench Project Manager. So we will talk about them on the end of this course. All this information will be about Ansys Workbench Project Manager. We will talk couple words about other product, but not for work with this product, but only for understanding what tools do we have with Ansys product. In reasons that most workflow and pipeline of works with CAE software start from changing geometry in several directions, in several reasons. We must review some CAD system that's present in Ansys Workbench. In Ansys Workbench there are 3 CAD systems: Design Modeler, Space Claim, and Discovery. Design Modeler and 2 others are very different software. Space Claim and Discovery are very similar. They have some difference, but Discovery it's more modern example of Space Claim. So we will do some review of interface, of methods of working with this product, and we will take a look for example of simplification process during Space Claim. In reasons that Discovery it's Space Claim with other interface and some additional features, we will not take a look about how we can simplify geometry and assemblies in Discovery. We will see difference, we will talk about difference, but it will be very shortly during first video about quick review. And additionally we will talk about the main model of Discovery. It's Discovery Explorer. Formerly in previous version it's called Discovery Live. Additionally, Discovery have Discovery Refine or Discovery Analyze, as it called previously, or Discovery Aim, also it called previously. But for my thoughts, Discovery Refine it's very cool product, but they need a lot of information that we will talk during lessons of Ansys Mechanical. And Discovery Explorer are very different product from Discovery Refine. So we will talk about Discover Refine, and we will talk about Discover Explore, and about Discover Refine we will talk much later, after ending a video of introduction to Ansys mechanical software. And also we will talk about some questions of working with general CAD system, such as SolidWorks, Inventor, Creo, Annex, CATIA, SolidEdge, and so on. About working with natural formats of exchanging 3D geometry, like Parasolid, ACES, IGES, and so on, and many other questions that can be very interesting and important during preparing geometry to calculation process. So, introductional to Ansys Mechanical will have two different courses. First of all, it will be a review of interface, and second will be introduction in calculation principles. So, courses in which we will review interface contain from 8 points, and will contain about 15 to 20 videos. Firstly, we will talk about why do we need Ansys Mechanical, some question about how to start it, where do we need to look some information, and so on. Then we will take a more detailed view about interface. We will talk about different tabs on the ribbon menu. It contains a lot of features and a lot of tools, so we will take a detailed view of all tabs of ribbon. And much more detailed view we will have about context tab, because context tab change their features and tools in context of points that you are working now. We will talk about this here. When you work with your problem and your task in Ansys Mechanical, you sometimes work with geometry, sometimes you work with mesh, with a boundary condition, with result, and so on. So, depending on what module do you use, on what step do you stay for this moment, context tab change their features and tools, and contain those number of different option. We will can have tab with features for project, for model, for geometry imports and geometry, for materials, for creating and changing coordinate systems, for working with mesh, for creating boundary conditions, for creating preferences about solutions, about transformation your geometry, about creating symmetry behaviors, about creating connections and joins, which will describe how different parts work with each other, about creating cross-section for beam and some shells, about creating virtual topology. It's a very interesting and cool tool for simplification of geometry inside of Ansys Mechanical. Created construction geometry that will not be useful for calculation in most cases, but can be useful for preparation some things and for analyzing result. Also, we will talk about advanced question about additive manufacturing process, its condensed geometry fracture, additive manufacturing process types, about some mesh modifications such as mesh edit and mesh numbering, and about result tab. It will be a lot of features, and we will talk about a lot of information here, but we will talk about only tools, about how to understand those results. We will talk later in other course. So this is three first points of this course, and we talk about them. After detailed interface review, we will talk about outline. It's tree of our computational problem, current computational problem. It contains all information that you must to control during creating a solution and during creating of analyzing your result. Also, we'll talk about the window which called detail. It's a very important window because in the detail we create a lot of preferences for any features, for any point of outline, and for all step of our analysis. Also, we will talk about working with right mouse button and context menu, because this context menu also as a interface and context tab depend on what do you select, depend where do you select this, and so on. Also, we talk shortly about wizard. In most cases, wizard don't use users now don't use this wizard, but it's very important and cool feature, especially for people who only start their way in finite element analysis and in using CAE software, CAE software. So we will talk about this wizard, and will be one or two short video with review of Ansys APDL. This video present here because I want to show differences between current version of Ansys Mechanical, modern Ansys Mechanical, and versions that 15 years ago called Ansys Mechanical. Now they called as Ansys Classic, Ansys Mechanical APDL, and this version have a lot of differences in interface and in types of works, method of works, and so on. But it has not only differences. Some things that work on a mechanical work very strange for people that doesn't know how it was historically. So some features and some moments from Ansys APDL, understanding of these moments, will be very helpful for understanding of how work Ansys Mechanical. So after this review, we will create two parallel flow. First of all, we will talk about basic features and principle of solving mechanical problems in Ansys Mechanical, and second, it will be about theory. So during Ansys Mechanical course, during basic features and principles, we will talk about main and basic mechanical principles. We will talk about some questions of general preprocessing, how to work with general CAD geometry, what you need to do and why you need to do that, for creating better solution, for creating more simple process of mesh creation and so on. Also, we talk about some question of meshing, only short number, but it's very important, because if you doesn't have this understanding, you will not be able to solve your task in a proper way and with affordable speed. After that, we will talk about some very strange for people who doesn't previously work with CAE software and FEA software, with FEA software. It's a question about interacting between different parts. So it's contact, it's joint, and so on. Much later will be more detailed course about meshing. Much later will be more detailed course about contacts, but we need to have some additional information between those courses. So we first of all will give some theoretical and practical information for users, and you will get some understanding. You will get a tool for improving your practice skills in FEA and Ansys. And after you have some skills, we will talk about more deep questions and backgrounds. Also, we will talk about main tools and main features for mesh creating. It's another question from the third on this list, because basic question of meshing, it's a question about theory of meshing, but very short theory. And main tools of mesh creating, it's simple practical tools that give very different result. We will talk about those results much later, but here you will see that Ansys have different tools that can give very different results, especially if you not only use different tools but use possibility to change some preferences of it. Also, we will take a look to loads and support, which called boundary conditions. How do we need to create it? Why we have different loads, different supports. We will talk about some difference here. Much more information will be in theory, but here we will have the main information. Also, we will talk about some type of mechanical calculation. We will talk about the main type of calculation. We talked about this calculation previously. We will talk about in previous video. We will talk about this calculation in next video. Here we'll give some understanding about how we work with static structural and what type of problem we can solve with static structural. We will talk about model, thermal problems. We will talk about how to apply a multi-step analysis for this type of problems. We will talk about some question of how to analyze result, what we need to do to show different type of result, and which type of result are most important for us for different type of questions and different type of calculations, and some short information about how to understand this result and what can we do to obtain not only different type result, but result for different geometry, for different part of geometry, and so on. Also, we need to talk about how we can update our geometry and finite element model, how to work with parameters, because in most cases we not very interested in only solve one problem, because in most cases of design process we need to solve it again and again, because we will see some problems in original design. We need to do some changes with this design, and we need to check how these changes modify the situation. Do it stay on the same position? Maybe it do some better things, maybe it do some worse things. So we need to update geometry, update all models and all preferences that we do for our calculation, and resolve these tasks and problems. But if you don't understand how this connection between CAD and Ansys work, you will need to repeat all these steps from the beginning, from the scratch, and it will be very big spending of times. You can do this process in those way, in those pipelines, that you will have minimal additional hand operation to apply changes in computational problem in reason that you change a CAD geometry. You need to understand why it works on those way, how to work with that, and also you will understand how to work with parameters to create more automatic way to review your design, to analyze your design, to find a optimal solution not by only your hand, but with one button. And also we will talk about very important questions. How to transfer information from one calculation to other. We will do it on an example of linear buckling and submodeling tasks. Then we need to talk about Ansys meshing, and we also, as previously, must talk about some questions which are very important for creating a computational mesh, because computational mesh must be not only present in your computational problem, but this mesh must be adequate. Adequate mesh, it means that it have balance between accuracy and speed. You need to have mesh with accuracy that you must have, and this mesh must be solved in the fastest way that is possible. So we will talk about creating mesh, we will talk about some information, what do we need to do for bettering process of mesh creation and pre-processing. We talk about types of finite elements. There are a lot of different finite elements, and we will talk about their types and what it can do with our problem, and where different type of elements can give some benefits to us. We talk about global mesh controls, we talk about local mesh controls, and during local mesh controls we will talk not only about changing size of mesh and do some improvements in local places, but about different method of meshes. We will talk about method of meshes during course Ansys mechanical review and introduction, and on those courses it will be very shortly. During Ansys meshing course it will be much more information. It will be not one video when we shortly say that it present, but it will be couple video, and all methods will have different video, and also we will have a video with comparison of methods and so on. We will talk about some troubles of creating mesh, and it will be different direction of this troubleshootings, because we can have troubles with creating mesh, and we can have troubles when we mesh already create. So in first side we doesn't create mesh in some reason, and we need to understand why the mesh not created. And in second we create mesh, it present, but it have some problem. For understanding how we can find this problem, we will talk about mesh quality criteria and tools and features of Ansys mechanical and Ansys meshing that can help here. So we will talk about tools that show quality of our mesh and help in analyzing of this quality. Also, we will talk about some methods and some tips and tricks how to simplify and speed up process of mesh creating. We will talk about creating virtual topology inside of Ansys Mechanical. We will talk about direct modeling and mesh editing inside of Ansys Mechanical, direct modeling of mesh and mesh editing. And also we'll talk about how meshing order can help, or in other way can do worse, our mesh process. It can help and do worse in a couple ways. For example, it can create more adequate and more speed mesh if we create this order by our hands. Also, we need to talk about shared topology and how it influences on mesh result. Also, we need to talk about how we can simplify mesh process by creating mesh for some parts of our assembly and then assemble these several meshes in one mesh. And we will talk shortly about how to see some statistic of our created mesh. So after this course you will have possibility to create mesh for 80% of task. And when I say 80%, I don't mean only a task for mechanical designers. I say for any type of problem, for any type of calculations that you want. So 100, it's any kind of mesh for any type of problem. 80%, it's almost all meshes. Theoretical questions, as you have seen on the previous slides, we have three different theoretical directions. First of all, it's a description of finite element method. There are a lot of books about finite element method and FEA analysis. There are a lot of video on different language about this, but for my thought, most of this video are directed on viewers that already have good math understanding, good math background, and can understand FEM in its real and original state. But for a lot of mechanical designers that only start their way in FE analysis, we must say that understanding are not so cool. So those videos that I will create will be with more simple language, with minimum of math, with minimum of formulas, and so on. We will talk about main idea and the finite element background. We will talk about basic finite element terms. such as nodes, elements, degrees of freedom, some terms from computational mechanics and numerical methods. Also, we will talk about some approaches that can be helpful for finite element analysis, and we also talk about load types because it's very important, and we already say that we will talk about load types and types of boundary condition in previous courses, and we talk here because it's very important, because here we can explain behaviors of construction with different loads and boundary conditions more detailed and in more understandable way. We'll talk about different types of finite elements. We'll talk about 1D, such as beam, such as bar, such as links, spring, and so on. We'll talk about 2D elements, shell, plate, membranes, and so on. We'll talk about 3D elements. We'll talk about simplified 3D elements. For example, plane symmetric, axis symmetric, and so on. We will talk about contact elements and special type of elements. Rigid joint, mass, XFEM, and so on. We will talk about main sources of different troubles, of mistakes, inaccuracies, errors, and so on. And how to prepare model for calculation. It's very important thing about this question we talk in previous courses. We will talk at these courses and in other courses because there are a lot of information that we need to describe. Also, we will talk about finite element method and analysis history, but I think it will be after main part of information. But understanding of history of FEM can give much more understanding why do different software work in a very similar way, something like that. So, question of computational mechanics. We'll talk about classification of problems, of type of problems, and we will classify this problem in different ways. First of all, we will classify by load behavior. For example, we will say that we have two different type of behavior. It's a static behavior and it's a dynamic transient behavior. And between those types, static and transient, we have additional types such as quasi-static and quasi-dynamics. Quasi-static, it's a general term, it's a regional term, but quasi-dynamics, it's not a general term, it's a term which creating with analogy by quasi-static, because it's a number of dynamic problems, but in those problems we don't solve full task, we simplify some process. Quasi-static, it's a situation when we have very low speed of changing of structure behavior of loads, and we can ignore these changes and solve any step as a static. Because we don't have any transient response, any additional bifurcations, any oscillation, and so on. When we talk about quasi-dynamics, it's we talk about construction which work in dynamics with those oscillations, but there are a lot of ways to simplify and not to solve transient problem with full integration. It's a question about natural frequencies and modes, response, different type of response analysis, such as random vibration, such as harmonic response, and so on. Also, we talk about linear buckling. It's very interesting type of task. We will talk about linear buckling in quasi-dynamic, and we will talk additionally about linear buckling because it's very interesting and strange type of analysis, and we need to understand that he have some similarities with natural frequency and modes type of problem, but have a lot of additional information that we need to review. We will shortly talk about fatigue when our construction work with some changes of our loads, and it have it will have cracks and fatigue, erosion and breakups during during work of this construction. Also, we will talk about different type of behavior of structure. There are main type of difference of type of different behavior. It's a linear and nonlinear. We will talk about this, and all question about nonlinearities we will have additional talk later. During this video we will shortly review that they have three main type of nonlinearities, such as geometrical, physical, and contact. We will talk what this type of nonlinearities, why it is important, and how we work with them. Additionally, we will talk about structural nonlinearities. Then we will talk about additional type of behaviors that were important in some moments, such as pre-stressed works, such as erosions, cracks, and so on, such as creep. We will talk about different behavior of material. We will talk about difference in isotropic, orthotropic, and anisotropic material. We will talk about difference between elasticity and plasticity. We will talk about different type of nonlinearities of material. It's physical nonlinearities. We will talk about which type of material in which situation have which type of nonlinearities and which type of material behavior. We will also talk about type of stresses and strains. We will talk about types of strengths, about robustness of construction, about their workability and erosions. Also, we will talk about some approaches of solving mechanical problem, how to simplify it, for example, with representation. We can simplify and change 3D geometry to shell geometry or beam geometry. Some short information about that will be in other courses, but here we will talk much more about this simplification. We'll talk about Saint-Venant principles and what this principle give to us. We will talk about principles that came from Saint-Venant principle and can give to us a lot of power. It's a method of subtraction and submodeling when we can take a closer look only for some small parts of our construction and assembly. But for adequate solving this problem, we need to talk for a lot of theoretical questions before. So, additionally, we will have some information about how different objects, how different construction, how different products work, why does it breaks, and so on, how we can analyze them. It will be also additional type of video, but it will be video without structure because we will take some objects and review it. So, disclaimers. If you are watching this video till this moment, I think you are interested in all courses that I say and some courses from second part that I don't review with more details. So I think that some disclaimers and important information can be useful for you. What's this additional information? I live in Kharkiv, Ukraine, and now we have a war in our country. Russia came to our country with war, try to occupy our cities, and if they can't occupy, they try to kill civil people, try to do a lot of strikes with artillery, with mines, with aircraft, with rockets. So, first of all, I try to do my best for creating this video, but I have some problem. Second, I already have created a lot of video before Russia start their invasion in Ukraine. Those video was in Russian language because we live in a region where Russian language are mostly commonly used, such as English in all other world. So I create my material in Russian. I have created about 700 and more hours of video lectures, and about 60% of this video lectures was created with this structure. I have created about 40% of all this structure with part 1 and part 2. So 40% of the structure was already created in a video lectures. I create a lot of text material about engineering, computational mechanics, and so on. Why do I explain that? A lot of people create their channel, give some promises to create cool content, and then see that it doesn't have interest in audience, and this channel closed and stop in creating video and so on. I work for this about 10 years. Last 3 years I create 500 of video, for example, and 700 hours of video. So if I will have possibility, I will create those lectures. I have material, I need to recreate it, and I need to recreate it in 2 languages. First of all, it's Ukrainian, because I live in Ukraine and we have no information in Ukrainian language about engineering. Not a zero, but we have small number of material in Ukrainian language. So I recreate all these lectures on Ukrainian language. Then I translate most important things to English and recreate it with channel of FEArytales. And video that I will translate in English, I describe with this video. I already have some Ukrainian materials, and they will be visible with bigger speed earlier. So please have patience. You can look Ukrainian language material with subtitles, with translation of subtitles, or wait till I recreate these lectures in English language. And for me, especially in reasons that we have war in our country, especially that I have 3 airstrikes in my house, especially that in a radius of 300-500 meters I have samples of exploded and destruction buildings, schools and universities. Sometimes it's very hard to find power and motivation to create anything. So any type of support will be very important for me as creator. Firstly, very simple to you. It's watching this video. It's likes, shares. It's commenting, creating questions, asking questions, and so on. I understand that my English is not perfect. I understand that I have problem in pronouncing and in vocabulary, but I hope my English is have enough level to understand what I try to say and try to talk. And additionally, if you have possibility and if you want to get early access to all this material, because it will be created and it will be posted, all this material will be posted for public access, but it will create firstly with early access, and then it will be published on public access. So if you want to help in our resistance, if you want to help in our war for our freedom, if you want to help in creating those contexts, and if you want to get early access to this video and many others, you can support with donation. Description of and links to Patreon you can find in description in details of this video. Thank you for your watching, and maybe peace be with you.